Bonsoir à toutes et à tous, et merci aux étudiants du CNSMD, Louis Darmaillac, Pierre Duclos, Matteo Pagès et Pierre Vanderscher pour leur interprétation de la chanson de Samuel Scheidt. Monsieur le recteur délégué à l'enseignement supérieur, la recherche et l'innovation, cher Gabriel Fioni. Monsieur le maire de Lyon, cher Grégory Doucet. Mesdames et messieurs les adjoints et conseillers de la métropole et de la ville de Lyon, cher Audrey Enoch, cher Chloé Vidal. Cher Jean Jouzel, ancien vice-président du GIEC, médaille d'or du CNRS. Mesdames et messieurs les enseignants-chercheurs, chers collègues, cher Olivier Amand. Monsieur le professeur Dennis Meadows, bienvenue à l'ENS de Lyon pour cette soirée exceptionnelle. Merci d'être venus si nombreux ou de suivre à distance nos échanges. Il y a 50 ans, Dennis Meadows et son équipe publiaient « The Limit to Growth ». Au-delà de l'immense contribution scientifique qu'il représentait en termes de modélisation informatique, ce rapport a eu un impact considérable. Pour la science d'abord, puisqu'il fondait une démarche systémique de modélisation sur des questions complexes. Pour notre société et ses décideurs, en lançant un avertissement majeur sur la limitation des ressources planétaires et en annonçant un basculement de civilisation au XXIe siècle. Pour le futur de la planète, enfin, puisqu'il fondait en quelque sorte l'écologie politique et les conditions d'un futur possible. L'accélération du dérèglement climatique ces dernières années et ses conséquences visibles partout sur la planète donnent une acuité d'autant plus grande aux travaux de Dennis Meadows. Si les turbulences du monde nous inquiètent, nous, en tant que scientifiques et passeurs de connaissances, nous devons apporter des pistes pour imaginer et tracer de nouvelles perspectives. Depuis les 50 dernières années, c'est la voie qu'a choisie Dennis Meadows, engagé également dans le développement de nouvelles approches sur la résilience. Aujourd'hui, les étudiants et les jeunes diplômés s'interrogent sur le sens de leur formation et de leur trajectoire professionnelle. Aujourd'hui, nos institutions d'enseignement supérieur et de recherche sont confrontées à un défi majeur pour s'adapter, se transformer, afin de contribuer par la production, la transmission et le partage des connaissances aux enjeux de demain. Aujourd'hui, Denis Meadows a rencontré des étudiants, puis des enseignants-chercheurs, échangé avec eux dans un dialogue passionnant au cœur des questionnements scientifiques et humains qui nous rassemblent. C'est une immense chance pour nous de vous recevoir et c'est un honneur que vous nous faites d'accepter le titre de Docteur Honoris Causa de l'École normale supérieure de Lyon. Après la cérémonie, nous écouterons votre conférence « Beyond the Limits to Growth ». Puis, vous participerez à une table ronde à laquelle Jean Jouzel a bien voulu se joindre également, consacrée aux enjeux de l'enseignement supérieur pour préparer nos étudiants aux défis de la transition écologique. Merci, cher Dennis Meadows. And for a short translation in English, 50 years ago, Dennis Meadows and his team published the Limits to Growth report. Beyond its tremendous scientific contribution, this report had a considerable and long-lasting impact. For scientific knowledge, since it started a systemic modeling approach on complex issues. For our society and its decision makers, by issuing a major warning on the limitation of planetary resources and by announcing a shift in civilization in the 21st century. For the future of the planet, since it established political ecology as a condition for a possible future. The acceleration of climate change in recent years and its visible consequences everywhere on the planet give even greater acuity to the work of Dennis Meadows. If the turbulence of the world worries us, we, as scientists and knowledge brokers, we must provide avenues to imagine and draw new perspectives. For the past 50 years, This is the path chosen by Dennis Meadows, also committed in the development of new approaches to resilience. It's a great honor for us to welcome you and that you accept the title of Docteur Honoris Causa from the École Normale Supérieure in Lyon. J'invite maintenant Olivier Amand à rejoindre la tribune.
Good evening, everyone. So today we give an award, but really the honor is ours. Dennis Meadows is an eminent scientist with an interdisciplinary background in chemistry, computer science, statistics, systems dynamics, and didactics. He obtained his PhD at MIT in 1969. Actually, I should have the pointer here somewhere to show you the slides. Here is Dennis Meadows. So he obtained his PhD at MIT in 1969. He has been a professor in several institutions in Europe and the USA, and he received many awards, including several Docteur Honoris Causa. So the question is, why all this attention? Dennis Meadows' work is an inspiration to many, and here you can see a very minimal list. In short, his work is a major stepping stone for research on systems and a founding element, if not the founding element, of political ecology. Dennis Meadows is a hero of sustainability. Here, I briefly want to share 3 highlights from a subjective biologist viewpoint. Okay. So first, Dennis and his team produced nothing less but the first computational model of the world. This model, called World 3, is a dynamic model of human activities triggered by the continued extraction of natural resources and exploring the socio-environmental implications. Because the model integrates interactions and feedback loops, it produces emerging properties, and thus it reveals the intrinsic autonomy of the system. This allows both the understanding of our current situation and the prediction of future trajectories over several decades. The main conclusion from what would be called the report to the Club of Rome, Limits to Growth, is remarkable. The model predicts a tipping point in the first half of the 21st century. This conclusion is a game changer. When it comes out, in 1972, there is massive media attention. The book is almost immediately translated in 35 languages and sold millions. But there is also a lot of skepticism and even denial. Yet, around 2000, the model is revisited and the conclusion is reinforced. So make no mistake, this is no science fiction. This is an accurate scientific prediction. We need to adapt to a world experiencing a major socio-environmental shift now. Importantly, in the model, this predicted shift happens even with access to more resources and even with cleaner technologies. So this quote from the report gives us a more precise prospect. Running the same system harder or faster will not change the pattern as long as the structure is not revised. So the right question is, how can we change the structure of the system? And this brings me to my second highlight. Dennis is deeply committed to education, both to explain what systems thinking is and the conclusion of the model. A very original point here is that Dennis designed many games as teaching devices, and here you can see 2 examples of his playbooks with creative games on system dynamics and on climate change, and you can find many more inventive games, including board games and computer games. So here you can see Fish Banks and Stratagem, that are probably the 2 most famous ones. With the focus on interactive games, Dennis provides us with a constructive path. Indeed, when we do not have sufficient material resources, our existence as humanity will have to rely on interactions. education is only the starting point. This is what Dennis' late wife and co-author Donella says here. The scarcest resource is not oil, metals, clean air, capital, labor, or technology. It is our willingness to listen to each other and learn from each other and to seek the truth rather than seek to be right. To be crystal clear, let me show this with a diagram. When we face a problem and when resources are abundant, we usually tap into the stock of resources to reach a solution. But this is very poor in terms of interactions, and it generates many negative externalities. On the contrary, when resources are scarce, we mobilize interactions with many heterogeneous partners, so the P's are partners. There is a flux of resources, and resources are constantly regenerated, and in the end, we find a solution. So in other words, when we extract less, we interact more. This is the first step to change the structure of the system. Do you think this is utopian? It's not, or at least not completely. This is how most ecosystems work. Little resources, lots of interactions. This is also what we see happening, albeit slowly, in our societies, for instance, with the rise of local support networks. And this brings me to the last highlight. Dennis Meadows continues to be actively involved in finding solutions for positive change. This happens notably within the framework of the Balaton Group that he co-founded in 1982. But here I take a recent example of his engagement in the context of the COVID-19 crisis, with this quote questioning our over-optimized world. Raising efficiency inescapably lowers resilience. Why is this relevant today? The 1972 Meadows report and subsequent work show that growth is threatening the viability of humanity. In other words, progress becomes counterproductive. When Dennis highlights the trade-offs between efficiency and resilience, he invites us to do nothing less than to change the compass of human progress from efficiency to resilience. In a fluctuating world, our path needs to be open and adaptable. This includes making mistakes and being tolerant about it. This has nothing to do with efficiency. To conclude, Dennis Meadows is giving us two gifts: a sense of the future and a future that makes sense. Again, here are the three highlights: the power of systems dynamics to understand our world and its link to natural resources, the importance of interactions as a model of society, and the idea that resilience is a response to the limit to growth. To the young audience today, our students, you can see that there are many challenges ahead. It's not going to be easy. But the good news is that this emerging, resilient, and adaptable world can be much more attractive than the current one. And it is already in the making. Agroecology, low-tech, new engineers inventing robust solutions, citizen science, bioeconomy, it's all on the rise. You will be the first generation with the legitimacy and the power to drive it. And from my biologist's point of view, this new emerging world is also very relevant. Living organisms are interacting resilient beings. So in some ways, this new resilient path also allows us to reconnect with nature, to be earthlings. So my very final slide is actually inspired by Professor Johan Negrosiu, founder of the Michel Serres Institute. We often ask the question, what planet are we leaving to future generations? With this visit to École Normale Supérieure de Lyon, Dennis Meadows invites us to ask another question. What future generations are we leaving to our planet? Thank you very much for being here with us tonight.
Par décision du Conseil d'administration, approuvé par le ministère de l'Europe et des Affaires étrangères, il vous est décerné le titre de Docteur Honoris Causa de l'École normale supérieure de Lyon. J'ai l'honneur de vous en remettre le diplôme et les insignes. You can have a few words if you want. Okay.
So I am very happy to be here tonight. It's a great honor to have this doctorate. It will go above my desk at home. ENS is a special university all around the world. And finally, I'm proud I have a connection with it. Thank you so much.
Le recteur, Gabriel Fioni, va nous dire quelques mots.
Dear Professor Meadows, the Mayor of Lyon, his deputies, Monsieur l'administrateur provisoire de l'ENS, ladies and gentlemen, and especially dear student, I want to thank you, Professor Meadows, for accepting that. It is an honor, not for you, it's an honor for us and for the full community of this academic region. Because what is important for us is that you and Jean Jouzel, you are example for the future generation. And let me address it to the student here. These guys had really a very strong conviction when they were more or less at your age. Professor Meadows decided to use a mathematical model, a very simple model. Mathematically, it's nothing. Simply differential equation, a system of differential equation, and to get the model turning, and to have, let me say, the strength to see what they were, the result, even if these results, I think, were not politically correct. And he did that. And let me also speak about somebody that I had the pleasure to know since a long time, is Jean Jouzel. Jean started making what? Something that nobody was caring about. Use nuclear methods to see trace elements in ice or in atmosphere. What for? And now, let me say 30 years is a bit more. 30 years after, everybody say that this person are visionary. But I wish you to do the same. Dare to get out of the normal path of science, the normal path of knowledge, and go ahead. I would say the same for Cédric Villani, that is here. Field medal in mathematics is the same. Dare, be sure, be convinced of what you are doing. And you know, after 30 or 40 years, you have two possibilities. Either people will say, oh, that is a completely crazy guy, or they will say, oh, this guy is a visionary. It's the same thing, more or less. Okay, and that is why, Professor Meadows, I thank you for being here with us today. You know, these are examples. And now it's your turn to take over. Thank you very much.